Let's take a few minutes to explore what your brain has been doing during your camping tonight. We hope you learned some new things and made some new memories. We're about to hear from our Chief Bioscientist, Jayatri Das, to tell us a little bit more about how our brains helped us do that.
The connections in your brain change every time you learn something. There's part of your brain called the prefrontal cortex, right up front, that makes your short-term memories. These memories are temporary, and unless you make an effort to remember, they disappear. You can usually store about 7 pieces of information in your short-term memory, and it only lasts just a few dozen seconds.
All right, come right on over this way, guys. All right, and you guys can put your stuff down. You can set your sleeping bags over there or over there. Welcome to Camp In here at the Franklin Institute. Are you guys excited for tonight? Yeah! Awesome. We're gonna have a really fun time. We have lots of stories.
We hope that your memories of camping last a lifetime. Let's learn more about how our brains make and store those memories.
Your brain forms 3 different kinds of memory: declarative, procedural, and emotional. Declarative memories are your everyday memories, facts, like what you did this morning, or what you ate for lunch, or the information you just learned in class.
Declarative memories are formed by the hippocampus, which is a region deep in the middle of your brain.
Your hippocampus sorts your short-term memories for long-term storage. It compares new information with previous knowledge and builds connections. Although there's no limit on your long-term memory, they can last a lifetime. Sometimes your hippocampus actually distorts the facts. You can even remember things that never happened. The word hippocampus is actually the Greek word for seahorse. And it's called that because the early scientists who studied this part of the brain thought that it had a similar shape. If your hippocampus gets damaged, you can no longer form new memories. Procedural memory is your ability to remember movements and habits that you do over and over. Think about how you talk, how you tie your shoe, or how you ride a bike. Your procedural memory involves a whole bunch of areas in your brain, but a main one is the cerebellum. It's that cauliflower-shaped region at the base of your brain. Emotional memories are when you remember how you feel during a particular experience, even if you can't remember all the details. For instance, think about how you feel happy when you smell something that reminds you of your favorite food, or how you feel sad when you hear a song that reminds you of a friend who moved away. A key region of your brain that helps you process emotion is called the amygdala. That's a Latin word that means almond. And it's sort of shaped like a nut. Even though it's pretty small, it's incredibly important because the amygdala helps you process fear, happiness, and all sorts of other emotions that help form your memories. There are lots of ways that you can actually improve your memory. For instance, try using more of your senses. Don't just read something, listen to it, say it out loud. Maybe you can even taste it. You can break down large amounts of information into smaller chunks that are easier to remember. Like phone number, we break it down into the area code, then the first 3 digits, and then the last 4 digits. You can connect new information to things that you already know, and focus on what you really need to learn. So quit multitasking and pay attention.
In a few minutes, as you set up your campsites and get ready to sleep, you might think you've hit pause on your camping, but let's find out what will happen inside your brain and body during the next 8 hours.
Your body controls your need for sleep using 2 different systems. One's called the sleep drive, and the other is the master clock. The sleep drive is the balance between being awake and being asleep. The longer you've been awake, the stronger you need to sleep. Scientists think that the sleep drive may be controlled by a small molecule called adenosine. Adenosine builds up in the brain over the course of the day as your body burns energy. If you drink soda or coffee that has caffeine, caffeine blocks the effect of the adenosine, helping you stay awake. Your master clock is located in a region of your brain called the hypothalamus. This is located in the middle of your brain behind your eyes. Now imagine that it gets dark outside. When the clock gets information from your eyes that there's less light in your environment, it signals to your brain to make more melatonin, a hormone that makes you sleepy. When your sleep drive and your master clock sync up, you're ready to sleep. Believe it or not, your brain is super active when you sleep. Your brain actually replays things that happened during the day, firing the same pathways that were active the first time you experienced something. The hippocampus and the prefrontal cortex communicate to build new connections and strengthen those memories. Your brain uses 20% of your body's energy, and all that action generates a lot of waste. During sleep, your brain clears away these harmful waste molecules that build up during the day. For kids and teenagers, your brain is going through a lot of changes. You're growing and learning every day. So it's especially important that you get enough sleep. Kids and teenagers need an average of 9.5 hours of sleep every night.
Your brain never takes a break. It's always changing. During the day, it's busy processing all kinds of information about the world around you. And at night, it's figuring out which memories are important to hold on to, and it's getting ready for the next day. But there's so much we have left to learn about the brain. So take care of yours, and maybe someday, you'll be the one to make the next big discovery.